So I'll start off by just welcoming everybody here tonight. Thank you for coming. I'm Regina Jorgensen. I'm the Director of Astronomy at the Maria Mitchell Association. And thank you all for showing up tonight. It's my really great pleasure to introduce Georgia Stolle McAllister, who is our new research fellow at the Maria Mitchell Association. And Georgia arrived about a month ago, I think, on island to work with us for the next year on some really interesting science, which she will not be talking about tonight. But tonight, she actually put together this fantastic presentation and trivia game in honor of the International Observe the Moon Night, which happened 2 nights ago. And so it's really, really great to have this sort of fun activity that we thought some people might enjoy, learning a little bit of about historical moon observations and then trying their hand at some moon trivia. And this was put together entirely by Georgia. I have just listened and I've learned a ton, and so it's really fantastic, and I want to thank her a lot in advance for putting together this really fun presentation. I feel like there was something else I was going to say, but I can't remember. I think Georgia's going to explain a little bit how tonight will go. I'll just mention, if you have any comments or questions, please feel free to, throughout the event, please feel free to put them in the chat or in the Q&A. And we will get to all of those at the end. We'll have some time for questions if you have general moon questions or whatever, or want to share something. We will be taking those at the end. And I think with that, I will introduce Georgia and let you take it away.
Thanks. So September 26th was International Observe the Moon Night. So hopefully you all got a chance to go look at the moon. And now tonight, in honor of that, we're doing just a little presentation on we're going to go through some of the scientific and artistic depictions of the moon, and then also some moon trivia. So the depictions of the moon are basically all European or Western centered artists and scientists, and they span a very long time range. But we jump around a little bit. So those all go in chronological order, but then the trivia questions are stuck in between those images, and they are not in chronological order. So don't be confused if we jump around a bit. And for the trivia game, we're using the Zoom polling feature. So for the questions, the question will show up on the slide, and then there'll be like a little pop-up box in front of it, which has the answers, and you can click your answer and then press submit. And we'll give a little minute for people to do that. And I'll read out all the options, and then you can choose which one you want to pick. And we'll show the results real quickly and then talk a little bit about the right answer. And there are 13 questions, but we are not keeping score. All of the answers are entirely anonymous, so you should keep score yourself if you want to keep score. And then, so at the end, we'll have a chance for people to share their artwork of the moon, which is something we partnered a little bit with the Artist Association of Nantucket to get people to draw or make some kind of artwork based on the moon, and we'll give you a chance to share that at the end. And then, like Regina said, you can go ahead and put any questions in the chat or the Q&A box throughout. Okay, so we'll start then. Our first moon depiction is from a very long time ago. This is a Neolithic moon map from about 3000 BCE. And it was found carved on the wall of a 5,000-year-old burial chamber in North Ireland. It was found in 1999 by Dr. Philip Stuke, who was looking for astronomy things in astronomy-related drawings or carvings, because at that time, people thought that the earliest known sort of mapping of the moon was in the 1500s, and he thought surely this could not be the oldest one. And he found these crescent shapes that were carved on the wall, and thought that they lined up nicely if you put them on top of a map of the moon. And so thinks that maybe these are some of the earliest moon maps. There are lots of other, there's lots of paintings and carvings of lunar calendars and some different star clusters or star collections of stars. And like in the famous Lascaux caves in France, with the cave paintings with the bison and all the other figures on the walls, that there's also like a series of dots, which people think maybe are a moon calendar, or that maybe show the Pleiades. So there's lots of people who've been looking at the moon, keeping track of the moon for a very long time. All right, so we're going to go to our very first trivia question, which is, what is lunar pareidolia? And the options are A, a feeling of restlessness, irrationality, or giddiness during a full moon. B, having the sense or belief that the moon is following you. C, the practice of naming or characterizing gods or goddesses after the moon. Or D, the phenomenon that causes humans to see faces or figures on the moon. So now there should be a poll showing up if I've done this right. And you can click on your answer and press submit. Yep, great. Okay, it looks like people can click on the, perfect. So we'll wait just a second, give people a chance to press the buttons. And if the poll's in your way, if you want to see the images, that you can drag it from the top, you can kind of move it around on your screen. Okay, I think looks like most people have had a chance. Do another second. All right, I'm gonna end the poll. If you don't have a chance, just put it in if you didn't get a chance to click the button, just think of it in your mind. And then I think it's sharing the results. Now you can see what people guessed for the most part. And it looks like most people, the majority, got it right. So D is lunar pareidolia, is the phenomenon that causes humans to see faces on the moon. So pareidolia in general is the tendency to try to find faces or patterns in images or sounds. So people thinking they hear like secret messages in music, or that's a type of pareidolia. Or if you look at the front of a car and see a face like with the eyes as the headlights, that's also pareidolia. And there's lots of shapes people can find on the moon. Great. Okay, so now we're going on to our second moon depiction here, also an old one. This is the Nebra sky disk from about 1600 BCE, and it's made of metal. It's about a foot in diameter, and it was illegally excavated in 1999 from Nebra, Germany. And it was dated then, and then it was sort of seized from the people who looted it a couple of years later. And it was all mixed in with with a bunch of Bronze Age tools. And so at the time, then it was dated to the same time as those tools, which is about 3,600 years ago. But because it was looted, it wasn't taken out, like the context of the artifact wasn't taken into account when it was excavated. It's very hard to actually date it and know that you have the right date. So more recently, the date has been disputed a little bit. People think maybe it's actually younger, from the Iron Age, because this is maybe a more popular motif that showed up then. And it got mixed in with Bronze Age stuff by the people who looted it. I think nobody is really quite sure. There's a debate. But it shows the sun and then the crescent moon, some stars, the Pleiades there, that group of 7 stars. And then the other crescents are maybe the Milky Way? Not really sure. I think it kind of looks like a smiley face. There's pareidolia there. But another example of people making art and observing the sky a very long time ago. All right, we're on to our second question, which is, besides the man in the moon, what is another common figure people see on the moon? And the choices are a rabbit, a dog, a tree, or a bird. And I put the poll up, I think. Great. Okay, looks like most people got a vote in. So it looks like a dog won the vote this time. But actually, so let me get out of the poll, sorry. Okay, actually it's a rabbit. So people see all kinds of things on the moon. And actually the man in the moon originally, even though now people think of it more as a face, originally it was a figure of a man carrying a bundle of sticks on his back, which is that top picture in the left, on the right in the top. But a rabbit, interestingly, shows up in lots of different stories in different cultures. So it shows up in Asian cultures, like in China and Japan and Korea, but then it also, and those maybe influenced each other, but then also independently shows up in cultures native to the Americas, like the Maya, the Aztec, and the Cree, all have a rabbit on the moon. Some of the stories are similar. So one common one is that there was a man who was traveling and he was very hungry and tired, and he needed to eat, and there was no food, but a rabbit came and volunteered itself to be eaten and sacrificed itself so the human could live. And so he put the rabbit up on the moon so that everyone would always remember its generosity. And it would be there forever. The other one that I think is maybe one of my favorites is a story from, I think it's the Aztec story, where there are two people who are going to become gods, and they have to sacrifice themselves in a fire to become gods. And one of them jumps right in and becomes the sun, and the other one hesitates and doesn't do it right away. And then eventually he does jump in and becomes the moon, but it's a very bright moon. But the other gods were apparently angry at him for being cowardly and not sacrificing himself immediately. And so the solution was to throw a rabbit at him, which stuck to the moon and made it dimmer, but also left the shape of a rabbit. All right, so our next image is so we've leaped ahead in time now. We went from the 1600 BCE to now we're in 1435. And this is when Jan van Eyck painted, he's a Netherlandish painter. He painted the Crucifixion and Last Judgment diptych, and it contains perhaps maybe the earliest known non-symbolic depiction of the moon. And I don't know if you can see it or not. It's sort of hidden in the background there. And if you look at it closely, like you can see the dark patches. It's really pretty impressive. He obviously spent quite a bit of time observing the moon. And the tilt of it actually even matches what it would be around 3 p.m., which is when Christ is said to have died on the cross. So Van Eyck spent a lot of time paying attention to the details of this moon in the background of his painting. All right, question 3. What is earthshine? And the options are A, light reflected off of Earth as seen from the moon. B, lights caused by humans on Earth as seen from space. C, sunlight that reaches around the edge of the moon, reaches the Earth from around the edges of the moon during a solar eclipse. Or D, sunlight that reflects off of the Earth and then off the moon. All right, it looks like most people got a chance to vote. So here we go. Here's the results. And yes, it is D. Earthshine is the word for the sunlight that reflects off the earth and then off the moon, so that when you look at the moon when it's a crescent, but you can still kind of see the whole rest of the moon, that part is lit up from light that's reflecting off of the earth onto the moon and then back to us. Which is pretty cool. And we go to our next drawing, which is by Leonardo da Vinci in 1513. And he drew Earthshine. So you can see it in this drawing on the left. He also had lots of drawings of the dark spots on the moon. And interestingly, he was probably the first to correctly deduce the reason for Earthshine. He had a chapter in his book, and it was called "Of the Moon, No Solid Body is Lighter Than Air," where he explained that ghostly part of the moon is actually lit up from a reflection off of Earth. He also thought that the moon was covered in water, which is not true. But still, it takes some imagination to guess this Earthshine reason. It's fun. All right, question 4. This maybe is my favorite question. Which of these were once reported in the newspaper to have been found on the moon? A, unicorns and miniature zebras. B, bison and sheep. C, bat people and biped beavers. Or D, all of the above. All right, if I can open the poll. All right, okay, here we go. Looks like all of the above. Yes, so this is true, all of the above. So in 1835, in a New York newspaper called The Sun, there were 6 installments of what is known as the Great Moon Hoax. They were written by Richard Locke, and they're entirely fiction, but a lot of people believed them. So he based it off of some sort of well-known facts of the time. He attributed these discoveries to John Herschel, who was a famous astronomer of the time, and he referenced journals and claimed to be getting this news from across the ocean and in sort of installments. And it made people buy lots of newspapers. And a lot of people believed it. So John Herschel, who was an actual astronomer at the time, at first he had a good sense of humor about it. He said he wished his own discoveries would be quite as exciting as bat people and biped beavers. But then he got annoyed because so many people from all over the world were constantly writing to him and asking him about these amazing discoveries of things like unicorns on the moon. But this image here is from the Maria Mitchell birthplace house, and it's based off of a wallpaper stencil, but it's hand painted on the wall, and it has in the bottom right corner, there's like people looking through a telescope, and then on the moon in that circle, you can see there's people with wings kind of towards the bottom, and palm trees and all kinds of fantastic things on the moon. So it's definitely a popular idea in the 1830s, 1840s. Okay, our next drawing is by William Gilbert from the late 1500s. And he was an English physician and a physicist. He drew the moon and drew the features of the moon, and he also started labeling them. And remember, at this point, there's still no telescope. So he's doing this all just by eye, just looking at the moon with his naked eye. and he drew these types of maps. But most of his work was actually on the study of magnets. So he wrote a book that at the time was like the main book about magnetism. And he started working out how magnets have poles and maybe how that's related to the Earth having poles and having magnetic poles. He was also kind of his own mythbusters. He liked to investigate folktales. My favorite was, does garlic destroy the magnetic effects of the compass needle? It does not, he found, but this was apparently something people thought of at the time. Okay, question 5. What is the lunar terminator? A cyborg assassin on the moon. B, the line between light and dark on the moon. C, the point at which an object falls out of orbit and gets pulled towards the surface of the moon by its gravity. Or D, a giant asteroid that hit the moon and formed the South Pole Aitken Basin, which is the largest crater on the moon. Okay, all right, looks like most people got a chance. So you are correct. It is the line between light and dark on the moon. So it's this line right between night and day. And it's interesting to observe that because there are mountains on one side. So the mountains that are on the dark side, the tops of them get lit up before the bottom. So that terminator line is kind of bumpy or rough looking when you observe it. And so for our next, that actually leads to our next drawing here. Thomas Harriot in 1609, he drew the lunar terminator. You can see it in some of his sketches here. He was an English cartographer, mathematician, and physicist. And he was actually the first to map the moon through a telescope, and also to observe sunspots. So a lot of people attribute these to Galileo, but Thomas Harriot actually had him beat by a couple of months. He just didn't publish his work, so it wasn't found out till later that his drawings are actually dated earlier than the observations that Galileo made. He did a lot of new work that he didn't publish. So he made really important contributions to algebra and optics. He sort of developed this theory of how light, this formula for how light bends when it goes through glass, which is known as Snell's law, and it's still used all the time. But he didn't publish it, and so Snell, who also developed it several years later, it's named after him instead. Thomas Harriot had a rather unusual death, perhaps. He died of a cancerous ulcer on his nostril, which sounds like a terrible way to go. Very uncomfortable. Okay, on to our next question. Question 6. If something occurs once in a blue moon, how often does it actually happen? And the answers are never, B, every 2 to 3 years, C, every 12 to 13 years, or D, 3 to 5 times per century. All right, I think I'm gonna close the poll. Show the results every 2 to 3 years. Yeah. So a blue moon actually has nothing to do with the color of the moon. The moon can sometimes appear blue if there's a lot of dust in the atmosphere. In 1883, when the Krakatoa erupted, all over the world for about 2 years, the moon looked blue. But the like name blue moon actually refers to when there are 2 full moons in 1 month. So historically, the definition was 4 full moons in 1 season, which is defined as between solstice and equinox. And there's normally 3 full moons in a season, and then every 2 to 3 years, there's a 4th one. Well, every 2 to 3 years, there's 2 full moons in 1 month. So that's the more common definition now. And it happens, it's going to happen this year, actually. So in October, there will be 2 full moons on the first and last days of October. And it's called a blue moon, I think mostly as a placeholder, because most full moons have a name depending on which season they fall into. But then when there's an extra one, it doesn't have a name, so it just gets called blue. And then this option D here, this 3 to 5 times per century, is actually how often there's a double blue moon, which is when there are 2 months in 1 year where there are 2 full moons per month. I hope that made sense. Okay, we're going on to our next drawing, which is by the famous Galileo, who in 1610, so basically the same time as Thomas Harriot, was also studying the moon and lots of other things. He was one of the first to study the moon through a telescope and to publish maps of the moon. You can see he has really detailed drawings. You can see the terminator over here, and then these darker patches that you can see on the lit up side of the moon. And his observations showed for the first time that there are mountains and valleys on the moon, which was pretty revolutionary at the time because people thought that anything in the sky was heavenly. And so it was perfect, and there were no impurities or like differences in texture. It was just going to be perfectly spherical and smooth. But his observations showed that this is not true, and it's actually, the moon is more like Earth in that it has mountains and valleys. And this is one of the things that, one of the many pieces of evidence that went towards showing that the Earth is not the center of everything. All right, question number 7. So we're jumped way ahead in time, went from 1610, so now we're in modern time for this question. So these are 2 modern images of the moon taken in radio wavelengths. What do you think causes that bright spot on the image on the right? And the options are A, aliens on the moon, B, an explosion on the surface of the moon, C, an asteroid hitting the moon, or D, signals from Earth that are reflecting off the moon. All right, I think most people got a chance to vote in the poll. Yes, so there are signals from Earth reflecting off the moon. If you look at the moon in radio wavelengths, it always looks full because, so even this picture on the left is also radio wavelength, but the light that we see with our eyes, the optical light, is from the sun reflecting off of the moon and to us. But if you look in radio wavelengths, which we can't see with our eyes, but you can use certain telescopes to see them, you're actually getting a signal that's coming from like beneath the crust of the moon, underneath the surface of the moon. rather than reflecting off from the sun. So regardless of what phase the moon's in, regardless of what it looks like with your eyes, this is basically always what it looks like with the radio telescope. And then if you tune your radio telescope a little bit to slightly different wavelength, and you pick up the one that where the band where all of our things on Earth operate, so things like our TVs and radios and cell phones, you get this bright spot because all of those signals that we're sending all the time are also getting pushed out into space, and they reflect off the moon, and then we can pick them up again on Earth. And these images were taken with the Australian Square Kilometre Array Pathfinder. All right, our next drawing is by Johann Georg Locher from the early 1600s. And he was a German astronomer and mathematician. He did a lot of the same observations of Galileo. Again, contemporary with Galileo, just like about the same time. And he made observations of the moon, Venus, Jupiter. He also looked at sunspots. But he came to a very different conclusion than Galileo. He stuck with the traditional view at the time, which was that the Earth was the center of the universe and everything was revolving around us. Whereas Galileo took the Copernican view, which was that the sun is at the center and the Earth is moving around the sun. And Locher published, along with his mentor, published a book with his observations and his theories, and then Galileo kind of tore it apart in his own book and ridiculed him for it. But he did a lot of the same, interesting that he did a lot of the same observations, just came up with a different conclusion. He also, this I thought was cool, he also thought the moon was translucent and made of some kind of a cloud-like substance, which was also sort of more popular at the time, the thinking that everything in the sky was not like the Earth, and so it must be made of some other material, something more heavenly, cloud-like. He also proposed the idea of an orbit being a perpetual fall, which is sort of similar to what Newton proposed and what we now think of as gravity attracting the moon to the Earth. So the moon is always falling towards the Earth, and this is what makes it orbit around. But Locher, even though he did all the math for it and figured out the physics of it, he actually did not believe himself that this was how things worked. He thought that this was just an interesting sort of theoretical, mathematical thought experiment, but that in real life this is not true because he thought the Earth was holding still in the center. Okay, question 8. What is the name for the scientific study of the physical features of the moon's surface? A, selenography, B, chymography, C, xylopyrography, or D, tachygraphy? All right. Wow, I think we have a tie here between selenography and tachygraphy. So actually it is selenography. And just in case you're curious about these other awesome words, chymography is the use of a kymograph, which is apparently a medical device that produces a graphical representation of change over time in things like blood pressure. Xylopyrography is the art of burning pictures into wood. And tachygraphy is an ancient form of shorthand, or the practice of rapid writing. So selenography is what we are studying currently. All right, so our next person, Johann Hevelius, in 1647, he was a Polish astronomer, and in 1647, he published Selenographia, which was considered to be the first atlas of the moon. So he would go out and observe the moon every night and then draw it, and then in the morning he would make engravings of it. And he put these all together in a book, in an atlas. He named a lot of the features of the moon, and those names stuck for a while. They were widely used at the time, but they have fallen out of use now, and we use a different system. Interestingly, he believed that naked eye astronomy was more accurate than using telescopes. So he believed that telescopes were for making discoveries. He used them to look at the moon, but he didn't think that telescopes were good for measuring the brightness of stars or figuring out the position of stars in the sky. And he would use other tools for that. And he published some of the most accurate star catalogs of the time. And some of his measurements, even compared to modern measurements, are really not too far off, which is pretty impressive. He was well known among his colleagues for having extraordinarily good eyesight. And he did a lot of his astronomy work in collaboration with his wife. His name was Elizabeth Koopman. And I like this picture a lot because I think it's funny, those little like angel cherub things in the corners doing astronomy. I think it's a funny little addition to the atlas. Okay, question 9. What does LRO stand for? And the options are A, Lunar Rover Operator, B, Lunar Reconnaissance Orbiter, C, Lunar Research Organization, or D, Lunar Retrieval Object. All right, end the poll and show you what people think. So yes, so LRO is for the Lunar Reconnaissance Orbiter, which is a NASA mission that was launched in 2009. And its goal is to make a 3D map of moon surface. So this is another type of selenography. And it is more accurate than your naked eye or using a telescope from Earth. So this satellite really produces some really cool images. Our next people are Giovanni Battista Riccoli and Francesco Maria Grimaldi. And I hope I'm saying the names right. Sorry if I'm not. They were Italian astronomers and also Jesuit priests. So Grimaldi was actually the student of Riccoli, and together they published a map of the moon, and they labeled the features on the moon using the same conventions that we still use today. So they were the ones who started calling all those dark patches, at least officially calling them, the dark patches on the moon that you can see. They started calling them Maria, which are just Latin for seas, and they don't have water, but they're produced from cooled lava that had seeped up and then cooled on the surface, and they make those dark spots that you can see. The two of them did some really interesting work other than this. Riccoli did a lot of experiments with pendulums and dropping things. He was trying to figure out gravity. And then he also published a lot of work on theology. And then Grimaldi did work in optics, especially. He was trying to figure out what light was made out of and how it reflects off of things and how it refracts through different materials. So they did a lot of work in addition to their astronomy work. And then since Grimaldi was the student of Riccoli and Riccoli was older, all of the work that they did together was published only under Riccoli's name. But he gave full credit to Grimaldi in everything they published. And Grimaldi did a lot of the actual observing work, And it's pretty interesting because at the time that wasn't always the case, that the student also got credit for the many hours of work that they contributed. So Riccoli and Grimaldi produced this naming convention that we still use. So naming the mare and also naming craters after people, including themselves. All right, our next question is one of these images more familiar? And if so, which one? All right, I think I'm gonna end the poll. Looks like most people got a chance. So yes, A is the image on the left here is the one you see anytime you look at the moon, because this is the side of the moon that always faces us. The moon is tidally locked to the Earth, so it means it's rotating at the same rate that it's orbiting us, so we only ever see one side of it. And then the far side of the moon is the one that always faces away from us. So this image was created by the Lunar Reconnaissance Orbiter by piecing together lots and lots of images that it took. It's interesting because the two sides look so different. Like the one that faces us has all of these maria, these darker patches, whereas the far side doesn't really have them, but has more craters. And one of the reasons people think this might be is that there's actually also different concentrations of minerals and elements on the near side compared to the far side. They think that might have resulted from how the moon was formed, from when it was formed, and then that there's more volcanic activity on the near side, which is why then there's this lava that seeped out and made these darker spots, which didn't happen so much on the far side, which is apparently less active. All right, our next drawing here is by Maria Clara Amert from the late 1600s. So we've gone forward by about a century from our last drawing. Or not from the last one, from the one before that. Anyway, in the late 1600s, she was a German astronomer and an artist. And at this time, women were not really educated, but she was, perhaps because she was the only one of her siblings who survived past infancy. But her father was dedicated to educating her, and he also apprenticed her took her as his apprentice. And he was an astronomer and an engraver. And he actually built his own observatory up on the city wall of Nuremberg. And Maria Clara Amert worked with him throughout her teens and her 20s. She did lots of studies of the moon, as well as Venus and Jupiter and Saturn, and made these really, really beautiful pictures. And a lot of them ended up being published under her father's name in his work, which is what happened at the time. But it was later realized that a lot of those paintings, she had actually signed them with her own initials. And so she's gotten more credit more recently. And she died pretty young. She died when she was only 31, but she contributed some really amazing work to to studying and picturing the moon and the planets. All right, question 11. What do Maria Mitchell, Sofia Kovalevskaya, Antonia Mori, and Caroline Herschel have in common? The options are A, they are all astronomers. B, they each did work that influenced the exploration of the moon. C, they each have a crater on the moon named after them. Or D, all of the above. All right, I think I'm going to end the poll and share the results. So actually, nobody got it this time. They're actually, each of them have a crater on the moon named after them, but they're not all astronomers. So Maria Mitchell, who some of you may know about, was an American astronomer. She was born on Nantucket, and she got her fame from, she discovered a comet in 1847 and was awarded a gold medal for it by the King of Denmark. And then she's often known as the first American woman astronomer, and she went and taught at Vassar for a long time. The second person here, the other people are also really cool. So Sofia Kovalevskaya was a Russian mathematician, and she did pioneering work in the field of partial differential equations. She got married in order to move to Europe and go to university in Europe. And then she got there and they wouldn't admit women, but she asked to unofficially sit in on her classes. And so she did that, and her professors, many of her professors recognized that she was just brilliant in mathematics. And she ended up being the first woman to get a doctorate of mathematics and be appointed a professor of mathematics in Europe. It took her a while though. She had a hard time getting there, but she did really, really cool work. And then Antonia Mori was an American astrophysicist. She was actually the student of Maria Mitchell. And she did her work on stellar spectra and on making catalogs of stars. She also analyzed she did the first analysis of a spectroscopic binary star, so two stars that are orbiting right around each other. And then Caroline Herschel was a German astronomer. She worked closely with her brother, William Herschel, who thought he saw cities on the moon, interestingly, but she did her own astronomy work as well, and she discovered 8 comets, and made lots of star catalogs. She's often counted as the first professional woman astronomer. And so for all of their interesting work, they each have a crater on the moon named after them. All right, so now we're jumping forward in time. When we were talking about the last one we talked about was Maria Clara Emertz, who was in the 1600s, and now we're all the way up to 1840 to the first photograph of the moon, or one of the first photographs of the moon, which was taken by John William Draper, who was actually the grandfather of Antonia Mori. He was an English-American physician, chemist, historian, and photographer. He did everything, but he was really interested in studying the chemical effects of light. He was one of the first, produced one of the first really detailed photographs of the moon. There were a couple of the photographs of the moon earlier than this, but his by far has the most detail. He actually, so the moon and people were some of the first things that people tried to photograph when this technology was being developed. He's also credited with producing the first photographic portrait of a woman, which was of his sister, Dorothy. And while someone else beat him to the very first photograph by a couple of months, he was the first to publish his results in Europe. All right, question 12. So we went from photographs to now up to the present time. We're back to the pictures taken by the LRO, the Lunar Reconnaissance Orbiter, and this is an image that it took of the North Pole. So what does this image show about the surface of the moon? And the options are A, elevation, B, temperature, C, density, or D, moisture. All right. Interesting. So a lot of people said moisture. It's actually the one in second place here. It's temperature. The LRO can measure the temperature on the moon, and this is where the redder color is hotter and the bluer color is colder. These are actually the minimum temperatures measured on the moon. But anyway, because the moon doesn't have an atmosphere, the temperature varies wildly. So on the equator, this is the North Pole, but on the equator, during the day, the temperature can get up to 250 degrees Fahrenheit. And then at night on the equator, it drops down to negative 208 degrees Fahrenheit. So those are some extreme temperatures. And then on the poles, it can get even colder. So I think the coldest temperature that was measured is at the bottom of Hermite Crater on the pole. It's at negative 410 degrees Fahrenheit. Pretty chilly. All right, so now we're moving on to wrapping up here, and these are some images actually from the Maria Mitchell Association. So these are pictures of the photographic glass plates. They were taken at the Nantucket Maria Mitchell Association at the Vestal Street Observatory with the historic telescope. So these are the photographic glass plates was a way for a long time that people did astronomy, where you had a very thin piece of glass and it was treated with a chemical that reacted to light, and you would slide it in the end of the telescope and get an image that way. So these ones they're like negative. So the darkest parts here are actually where the most light hit the plate. And these are both of the moon. And it's pretty cool. You can see the terminator line. You can see how it's all jagged. And this one too, you could kind of see it along the edge. And this was the way astronomy was done for a long time. Okay, we're on our very last question, which is, where is Maria Mitchell's crater? So we know she has one named after her, but where is it on the moon? And you can, if I can make the poll happen, you can choose one of these spots, A, B, C, or D. And by the way, this image of the moon is the full moon that's going to happen in a couple days. So if you go out and look at the full moon, you can kind of try and it'll be in this orientation, so you can kind of try and figure out if you can spot Mariah Mitchell's crater yourself. Okay, here we go. So it's pretty evenly split. Yeah, it's basically just a guess, which is great. So this B was, the answer is B. Mitchell is this little tiny crater. So this bigger one here, I think you can see my mouse, I hope. This bigger one is called Aristotle, and then Mariah Mitchell's crater is sort of just right next to it. It's a little bit smaller. This big dark one up here is named after Plato. This dark one over on the edge is named after Grimaldi. Remember, he was one of the ones who started the naming convention of the lunar naming convention. And then over here, there's these two tiny little craters, tiny little dots next to each other, and they're actually both named after Messier, who was a French astronomer. And there's lots, he has a whole catalog named after him, but he apparently gets Messier and also Messier A on the moon. And then, oh yeah, and then all these darker patches are also labeled here, just if you want to try and see if you can find them when you go look at the moon. These are the names of the different Maria, which are, again, they're caused by the lava, the cooled lava that seeped up from underneath. All right, so this is the end of what I have to share with you. And so now, if you would like to share your own artwork, which we hope you do, you can do it now. So if you can raise your hand, or you can send a chat message, and then what happens is we'll have to make you a panelist so that you'll be like kicked out of Zoom for a second, but don't worry, it'll just automatically push you back in, and you'll have all the powers to be able to turn on your video or share your screen. Also, if you have any questions, please put them in the chat or in the Q&A, or you can raise your hand and then we can let you talk out loud also. Thank you so much for participating.
Thank you, Georgia. That was excellent. And we do actually have one hand already. Laura, I'm going to, let's see if I can, it's just saying chat. Why is that? Usually I can unmute. Georgia, on your end, do you see the ability to unmute or make a panelist? You might have to do that as from the host.
Yeah. Sorry, it's gonna take me a second. I haven't done this before. I think I have to stop sharing.
And then if you click at participants in the bottom of your screen, it'll open up that side.
Yes, so I can allow someone to talk.
And then I think you might have, there should be an option there that says make them a panelist.
Yes, promote to panelist. Okay, Laura.
Laura, hang on 1 second. It's going to kick you out and then it'll bring you back with the ability to turn on your screen.
Oops, I think I did it before you stopped talking. There we go.
Start video. Okay, hi.
Hi.
Tonight, Eric, do you want to share yours?
Oh,
That's awesome.
that is awesome.
We did these as a family. This is his brother Patrick's, who's a little camera shy this evening, but enjoyed the show. And
Oh, I see some mare there.
with the mare.
Or a bat person, perhaps.
Beaver, I don't know.
Yeah.
What night did you all go out and observe the moon?
We went out Saturday and Sunday.
Nice.
Nice.
We had some nice weather, which is nice.
Yeah, with our binoculars.
Oh, perfect. That's a good way.
And what was your kind of favorite? Did you see any creatures or figures?
Patrick said he saw someone shooting a musket.
Awesome.
All right.
I saw a dog.
A dog on the moon? Cool.
So anyway, so we enjoyed it, and we really enjoyed learning more tonight.
Thank you so much for sharing the artwork too.
Thank you.
Those are great.
Thank you so much. Georgia, we have one more person who has their hand raised. Kara.
I don't see. Oh, yep. Okay, found you. All right, I'm promoting you to panelist. I don't know how to unpromote anyone.
If you click on their name, if you hover over the name, it should allow you to unpromote.
Oh, cool.
Ooh, that's awesome.
Want to tell them about it?
Yeah.
So, hold on. What's this say? So, I did this with oil pastels, and we went to observe the moon on the beach the other night. I usually just see a man on the moon, but tonight it's kind of like a man with craters. So, and then the Earth over here, and I tried drawing the Milky Way.
Wow.
So,
Very cool.
Ooh, yeah.
That's awesome. They even kind of look three-dimensional the way you've painted them. That's fantastic.
Does your moon have, or does your Earth have like clouds on it too?
yes, it does.
I love the face on the moon also.
Yeah. That's awesome. Thank you so much for sharing. That's really awesome.
Thank you for sharing.
If anybody else would like to share or chat or ask any questions, feel free to do that. I do have two people who sent me artwork that I can share for them if there's, I don't see anybody else with their hand up immediately. So I'll go ahead and try to share these from my end, if that's okay, Georgia. I think you have to enable screen sharing for panelists.
Okay.
Which should be down at the bottom, maybe,
It's on the bottom.
perhaps.
Don't see it.
Under share screen.
Oh, under share screen.
Yeah, if you click on share screen, it should say allow.
10. Great. I think it's.
Got it. Yeah, perfect. Okay. Can you see my screen?
Yes, I can see it.
Okay, so this first one was submitted by Lily Walker McGloin, and it is entitled Elder Space Cat Couple Living on the Moon, which I also love, and thank you so much for submitting. That's really fantastic. Lily is 12 years old, and I did not unfortunately ask which night she went out to observe the moon, but from my guess, this kind of looks like a full moon, so.
That's really fun.
And
there's a pattern in the background too.
yeah, the pattern in the background is really awesome. And it looks like you have Saturn up there, and yeah, it's really cool. And then if I'm scrolling, can you see as I scroll?
Yes.
Okay, and then Kim Botello, who's our Director of Education here at Maria Mitchell, she was actually here, but she had to run off to an emergency, and so she just asked me to share some of her photography that she had done of the moon, and I picked out a couple. She has a lot of great ones, and she said that she did these with, so they're photographs, and they're long exposure photographs that she moved the camera, kind of holding the camera and moving it with a slightly long exposure. And that's how she was able to create these really great images. This one's cool. And then I like this one as well.
Yeah, they're so swoopy.
Yeah.
Those are really nice.
And let's see, we have a question in the Q&A. Linda is asking, why is the moon high in the sky sometimes and other times it is low, like now? would you like to take that, Georgia?
I don't think I have a super good explanation for it, so I'll let you do it if you don't.
Okay, yeah, no problem. Well, the height in the sky depends on a couple different things. First of all, it depends on what time you're looking at it. So if you happen to go out and look at it when the moon is rising or setting, it's going to be near the horizon because it's either rising or setting. But then also the moon, like the sun, follows something. Okay, Linda just clarified that she means at the peak of its arc. So that's what I was about to get to. So the moon and the sun both follow something called the ecliptic, which is kind of an imaginary arc on the sky that is higher up in the summer and lower down in the winter. So it's a function of the season, really. So you'll notice in the summertime, the sun and the moon appear to be much higher in the sky with respect to kind of the horizon. When you say look south, they tend to be they are much higher. The ecliptic, that line that the moon and the sun and actually all the planets follow, is higher in the sky in the summertime and lower in the sky in the winter. And what that line actually is it's just the plane of our solar system. So all of the planets orbit more or less in a plane, kind of like a pancake, and we're inside of the pancake and we're looking out, and that makes kind of a line that everything, the sun and the moon and all the planets, appear to follow in the sky. So that's basically the answer. It's a matter of seasons, where in the winter it's lower and then in the summer it's higher up here on Nantucket. This changes, of course, if you go to the southern hemisphere or it's a function of your latitude on the Earth. I hope that answered your question.
Are there any other questions?
Let's see. I don't see any yet, but we could wait a minute. Oh, Linda's saying it seems like it's different for the sun and the moon, and it is slightly different. So they don't track like on the exact same path. They are slightly different. And in fact, that's why we don't have eclipses every month, because the plane in which the sun and Earth, and then the Earth and the moon exist they're slightly, I'm exaggerating here with my hands, they're not exactly the same, they're slightly shifted. And so that's why we have eclipses only, every once in a while and not every month. So they don't exactly pass kind of behind each other from our perspective. Very keen observational question. That's really awesome. Kara is asking, is the orbit elliptical? And I'm assuming you mean the orbit of the moon. And yes, it is elliptical. Like most orbits of planets and moons and more or less everything, the orbits are technically ellipses, so they're not perfect circles. They tend to be ellipses, but they tend to be, more or less circular, but technically are ellipses. So yeah.
So there are some times when the moon is slightly closer to us and sometimes when it's slightly further away.
That's right.
Whether it's at the long stretched out end of the ellipse or the little more flat end of the ellipse.
And to follow on that, that's when we get these supermoons that the news loves to talk about. When they say, and you'll see all these social media posts where it's like the moon is so much more, it's giant right now. While really it's only maybe about 10 to 15% bigger in appearance in the sky, which is a little bit, it's really hard to discern that with our eye, actually. And so that supermoon thing is always a little bit frustrating as an astronomer, because people get really, really excited about it. But actually, scientifically, it's not, there's, yeah, the moon is slightly closer and it looks slightly bigger, but it's really much, much bigger of an effect is actually, and you all probably have seen this, when you see the moon on the horizon, like when it's either rising or setting. And that is actually something, an optical illusion that causes our brain to see the moon as much, much bigger than it actually is. And you can test this yourself if you do see like a full moon rising, and you take a piece of paper and you can make a circle that just is the same size of the moon, look through it, and you're kind of measuring the circle, you know, tape that shut. And then wait 3 hours or 4 hours until the moon is up in the sky and use your same measuring tool, and you will find that they are exactly the same size. However, to your brain, it'll look like the moon when you observed it on the horizon was so much bigger than when it's up in the night sky. And as far as I know, nobody really understands or can explain this very well. There's sort of different explanations out there for what this effect is, but it's definitely an optical illusion. So it's something inside our brain. And some people say it's because you can compare with things on the horizon when it's down low, and when it's up in the night sky, you know, you just see a blank canvas, and our brain somehow can't compare it to anything. And so when it's on the horizon, we can kind of, we imagine it being much bigger somehow. Have you heard of that as well, Georgia?
Yeah. I think Kara had a follow-up question of how much closer and further away can the moon get from its normal path? So its normal path is an ellipse, like you said before, so it is always on its normal path. But the farthest it gets is I was just looking at this, so it's about 91 million miles. No, this is the sun to the earth. Sorry, that's the wrong number. I'm not sure what the moon is actually, but because the earth also goes around the sun in an ellipse. But the moon to the earth, I'm not sure what those distances are, but it's not a very big difference.
Yeah, the number I always remember for the moon is 200,000 miles. So that's the rough distance that the moon is from the earth. I don't know off the top of my head though what the change is in, you know, the difference in this elliptical when it's closer and farther away. I suppose it's about 10% of that. So plus or minus 20,000. So maybe like 180 to 220,000, something like that. Yeah. Let's see, do we have any more questions, or anyone else who feels inspired to share any artwork? Please feel free to raise your hand, or if you'd like to ask a question but you don't want your video on, we can also just unmute you and you can just ask your question as well. Okay, well, I don't see any other questions or hands raised. So I would like to, first of all, thank Georgia for putting together this fantastic presentation and quiz. I learned so much watching this. It was really great and so much fun trivia. So thank you so much, Georgia. And to everyone who attended, thank you so much. And for those of you who shared your artwork, also, thank you. I'm so impressed. It was really, really fun to see everyone's art. And I want to just say thank you to you all. Keep looking skyward and keep observing the moon. So
thank you all so much for coming and for participating in the trivia game and sharing your artwork. It was a really fun time. All right.
All right. Thanks so much. Have a good night.